Welcome to the Green Wasp Removal YouTube channel. In this episode, we continue training and mentoring the Manchester University Wasp team as we take on a super aggressive native yellowjacket species called Vespula flavopilosa, also known as the Downy Yellowjacket for the soft, fine hairs on its body. This species came out swinging. They were ready to attack instantaneously with dozens of stinging wasps all over our gloves and our suits and our veils. And it turned out this was the first time we had dealt with this particular species of wasp in our area. As you can see here, they came out to attack instantaneously as soon as we disturbed their nest, which was a ground nest underneath the mulch of a private residence. So in this episode, we'll show you the entire process from how we identified this species that was fairly new to us, and then how we pulled the brood comb out of the ground after we dug it up, and what we did when we tracked the queen down to make sure we had her contained. We'll show you how we collect all the adult wasps in the nests for Venom Immunotherapy. And Venom Immunotherapy involves allergy shots for patients who have severe or lethal venom allergies, so the great majority of our wasps go to that purpose every year. We'll show you how we preserve the venom in these wasps by flash freezing them in dry ice or frozen CO2. This protocol preserves the venom for biomedical use at the highest possible quality. Then we'll show you how we bring the brood comb back to the vespiary lab that we operate that allows us to raise the eggs and pupae and larvae in the nest until they can hatch out as adult wasps. We'll give you a look at what life stages are inside this nest. As you see here, there's larvae in the nest, and these larvae, once they mature enough, they weave a silk cap over their nest, and what you see here are a lot of those silk caps in the brood comb. And those are primarily what we allow to hatch out in captivity so that we can collect them all as adult wasps for Venom Immunotherapy. We'll also show you how we feed the wasps in captivity with a plant-based protein called pollen cake, which you see here. They really did well with this. We tried this for the first time in 2025 with multiple different species of wasps that we were raising in the vespiary, and all of them did very well eating this as protein and even a little bit of carbohydrates. So all they needed was pollen cake and water, and they did quite well in captivity. For now, we'll take you back to August 2nd of 2025, and we'll show you the entire job from the initial inspection all the way through to putting them into our vespiary. As always, we thank you for riding along with us. We hope you enjoy the show. If you do enjoy the content on our channel, please remember to like, share, subscribe, and comment to let us know you're there. All right, it's August 2nd, 2025. We're at a private residence, and they have a foundation-based yellowjacket nest. Take a little species identification here by grabbing a specimen, knocking it out, taking some pictures. Here during the initial inspection, we like to show up and immediately get a specimen to check it out and look at the pattern on the back to identify what species we're dealing with. And in this case, the markings on this wasp showed it to be a Vespula flavopilosa. This species is sometimes called the Downy Yellowjacket because it has soft, fuzzy-looking hairs all over its body. It's kind of a prominent feature. One of the identifiers we look for with this species are the two vertical yellow marks in the thorax that you see in the red circle. They don't cover the thorax. They don't go from end to end vertically, but they're small, two small yellow vertical marks. We also see a black arrowhead shape on the first tergum, and that is also an indicator that this may be a Downy Yellowjacket. These marks sometimes look different, sometimes they're not always present, but if you look at enough of them in a colony, you're usually going to see these. The arrowhead shape on the abdomen is similar to German yellowjackets, so sometimes they get misidentified, and we did that on our initial look at this species. We immediately thought German yellowjacket, but then the behavior was different than Germans, and the paper on the nest was different than Germans, so we knew it must be something else, and then we re-examined them closely, found out it's flavopilosa. So you have to be careful with quick field identifications. Sometimes you can make a mistake if you work too quickly and you're not looking at every detail. So after the initial inspection, we went back the following week to dig the nest out. All right, it is August 8th, 2025, and today we are dealing with a foundation-based yellowjacket nest. It's either up under the siding or in the block or down in the mulch. We don't really know for sure yet. We'll do a little mulch digging just to get some of that debris away from the wall. I'm here with Colleen today from the Manchester University Wasp Survey team. Colleen, let's get you set up here, and what we're going to do is have you just put that collection device right up next to the hole, and we'll just do some collection first before we dig, and then we'll remove some mulch. All right, firing up. Check that pressure, make sure they're not getting beat up too much. Now I'm gonna go get set up at the greenhouse. Once that's up and running, I'm gonna come back and we'll dig some mulch away to try to find the entry point. Okay?
Sounds good.
All right, I'll see you in a bit. How's it looking?
Pretty good. Must be a decent sized nest because there's been a fair amount of forager activity the whole time.
So good job. Looks like so far they're healthy. It's good pressure. Let's remove some mulch, try to find the entry point. I think what we'll do, let's pull that up, turn it up, the spout so it faces up, and then we'll just pull the stick back for a minute. Get the pole out of our way while we kind of clear this space. There you go. All right, what I'd like to do is see what's in here and try to figure out whether they might be underground. If they are, if we get lucky, they're right adjacent to the foundation instead of actually being in the foundation. Am I in the right place here? Yeah, there they are.
Yep.
Okay, let's bring the pole back. And just sort of leave it facing up for a minute. All right, let's step back while they get collected. So as you can see here, this was an extremely aggressive nest. Dozens of them came out and instantly stung. And this was clearly not a German Yellowjacket nest. That they would never react that way. That's an attack on the gloves. Crazy. Look at that. As soon as we saw this intense defensive reaction from this nest, just from disturbing the mulch, we hadn't even touched the nest yet, we knew that this was probably some species of native yellowjacket, because all of our native yellowjackets, eastern, southern, flavopilosa, a couple others, they all react very, very defensively and intensely, whereas German yellowjackets, Vespula dramatica, they simply don't do that. They're much less aggressive than our native wasps. So ultimately, after re-examining the nest and the wasps inside it, we realized we were dealing with Vespula flavopilosa, which is called the Downy Yellowjacket, which was an exciting development for the team because we had never actually come across a flavopilosa nest before. This was the first time we dealt with one. We had found them in our feeding traps before. When we take a feeding trap and put it outside and we try to assess which species are in the neighborhood, every now and then, rarely, we would find a flavopilosa individual forager, but we had never found a nest. We didn't even have a flavopilosa collection bottle, so we had to clean out one of our Germanica bottles and use that as the collection device for this nest. So you'll see Germanica on all of the bottles during this episode, but it's actually flavopilosa because we didn't have any flavopilosa containers at the time. We do now. So as you can see here, we're assessing how far we have to walk away from the nest before they stop attacking, and these took a long time. We had to walk quite a ways before they'd stop attacking. So you see how this wasp is stuck in the glove. They cannot release themselves from leather, and I'm not really sure what that's about, but human skin, they can get on us many times and sting you many times. But as you see here, in a leather glove, they simply cannot get out of it. So they will disembowel themselves, as you see her in the process of doing, in order to escape, but then they die, like a honeybee. But in general, a wasp does not die like a honeybee. They have a smooth stinger. It's not barbed, like a honeybee stinger is barbed, so as soon as they sting once, they die, even in human skin. But wasps are different. They can sting you many times in human skin, but if they go into leather, they get stuck. So they're still quite active. So we're gonna let them go ahead and keep getting collected here for a few minutes. Hey, with any luck, we can dig that nest out. So we lucked out. It's right there on the surface by the mulch. So instead of being in the block or the siding where they're inaccessible, you can actually reach the nest. What you see here is the top layer of comb on the nest, and it doesn't look too huge. Here's the circumference here. So it's probably several layers deep. So what we're gonna do is get some trowels down there and lift the whole thing out like a hamburger and set it right into this glass habitat. We'll be looking for that queen the whole time. So as you can see right here, this is the edge of the paper that they put around their nest. Very delicate paper. And they've done that all the way through this mulch. And so we're going to expose all of that. If you start getting hit by too many, just back off.
I'm good right now.
Okay.
I think we did a good job letting a lot of them clear out.
Yeah, man, it helps a lot. You don't always have time for that, but man, when you do, it makes a big difference. Okay, so what we see here is the outer paper envelope that goes all the way around the nest. And between that and the dirt, there's a big gap. It's about an inch or 3/4 inch gap all the way around it. And they suspend it within that gap by little stalks all the way around it. So it's a little world of its own, just sitting in space, attached only by a few stalks to the substrate, the earth. Really amazing engineering. That space in between insulates the area, ventilates the area, and allows the wasp to pass in and out of the envelope on the outside as the nest gets bigger. You see that real quick. I'm going to zoom in here for a sec. So here's the outer envelope. Here's the space in between the dirt and the envelope that goes all the way around. And here's the inner comb where all the eggs, larvae, and pupae live. I think I'd like to have a little more pressure. So Colleen is adjusting the pressure on this rig by taping up some of the holes we have drilled into some of the sections of tubing. That's because these vacs don't have adjustable pressure. And so we adjust all our pressure through removal and application of tape as needed on the drilled holes in the pipe. Okay. All right, I think that'll be okay. All right, let's lift this thing out of here. Okay, now we're going to do a close-up down here. So they were actively digging through here to make a wider space as this nest grew. They were going further and further down along the side of the foundation. So what we're going to do is look for the queen. In case she's not in here, she's going to be down here at the bottom, because the bottom is always the newest comb. And that's where she'd be busy laying eggs most of the time. So here we pause the dig a little bit while we take a very close look at the paper. The paper is a fascinating material. It's made out of wood fiber and plant material that the wasps chew up and mix with their saliva and then they cover all of their brood comb in these swirls of paper. When they first make this material, it's kind of a paper mache clay-like substance. It's wet and moldable, and they mold it onto the existing paper and keep expanding it, and it dries very quickly into this material that becomes very lightweight, very functional, very airy paper. With a couple of the species that are native species here in the Midwest that live underground, like Eastern Yellowjacket and flavopilosa, like you see here, which is the Downy Yellowjacket, the paper is very, very lightweight, very easy to crumble, very, very delicate. Whereas when we're dealing with a German Yellowjacket, which is an invasive species here in North America, the paper is a little more firm and can take a lot more touching than these native papers can. And it's worthy of note that some of the darker swirls you see in this paper are from a darker colored wood. It could be the mulch you see here on the ground. It's a similar color. A lot of our native underground wasps enjoy mulch as a place to nest. So here we're just finishing up our queen hunt, just to make sure we don't miss a queen down here in any of these nooks or crannies or any of the new tunnels they were starting to build while they wanted to expand the nest.
Yeah, they had tunnels all the way down here.
Wow.
Right here is where they were headed. But it looks like that's it. Okay, let's treat it with some of the essential oil spray, non-toxic, soap and water and essential oil, and then we'll refill it. So what we're doing is a queen hunt. We're dropping each of these combs over until we find our queen. And we want to see her. There she is. You got her? She's under this small comb right now. Can you see her?
So here we located the queen. She was in between some of the comb layers. It's important to find the queen if you can, just to prevent the nest from rebuilding, and also because you can then use the queen when you put this nest into incubation. In the vespiary that we operate, we have multiple different types of species that we're raising all the time. And when you have a queen in the nest, it just functions more normally in the free-range vespiary environment. So we like to capture the queen with the nest whenever possible for that reason as well.
Yeah.
Right there in the corner. There she is.
Yep.
So we want to just make sure we have the queen so the nest can't rebuild. So we're good. We know we have the queen contained. So now the nest is out of the ground. Colleen, good work today. Thanks for your help. Over here, we just now have to spray a little non-toxic essential oil mix in here. That'll deter them from coming back. We'll spray it in the hole, then we'll refill the hole with dirt and mulch, and we'll spray it again. That will deter them from coming back. And those that are out in the environment now, when they come back from all this plants and stuff, they will realize there's no more pheromone that they recognize, and they'll hover around for a couple days, but then they'll starve out on their own. No need to spray them. If you ever run into this, they'll die off on their own, the ones that come back, because without the nest, they can't survive. So Colleen is now going to cap off our collection bottle, and now we have our yellow jackets contained. Definitely a busy collection. No wonder they came out swinging so hard. That's why there was an explosion of activity when we hit the top of that nest. They react like killer bees. Germanica just don't do that. So today, Colleen from the team gathered up a whole bunch of yellow jackets for Venom Immunotherapy. Good job today. I appreciate you coming up. All right, so Colleen is now applying a non-toxic essential oil spray. It's got peppermint, clove, and lemongrass mixed with dish soap and water. And what this does is it kind of blocks the pheromone so that any foragers that return from the environment, they're aware that this no longer smells like their house. That's good for now. Now we're going to refill it with dirt and do it again. So now Colleen is going to go ahead and freeze these specimens. We're going to detach our container and just drop the pole. And in the vehicle, we've got dry ice, which is CO2 in the frozen form. And that's a great thing to have for biomedical use because it's cold enough to freeze the venom at the highest quality instantaneously. So this is CO2 gas you see sublimating into the air. There's no liquid form of CO2. It just goes directly from frozen to gas, frozen solid to gas. So very handy in the field. There's never a liquid form to deal with. And it's super cold. If you were to use this ice and not have gloves, if you touch it, it can burn you like a hot coal if you hold it longer than just a second. You can't touch it with skin, but it has to be really fast. If you any longer than that, you'll get burned. Okay, put that scoop on the roof, and then you're going to take this bucket and bury it sort of evenly spread across the top of the container. And go kind of slow so it doesn't spill everywhere. So CO2 gas is the same thing that we exhale. So it's non-toxic, but you don't ever want to breathe it in concentration. Because if you were to breathe this gas in too high a concentration, it can replace the oxygen in your lungs and it can actually kill you. Even though it's a non-toxic gas, because it will replace oxygen. And that's why ventilated areas are fine, but if you're ever doing this in a super enclosed environment, you'd have to be careful of CO2 exposure. Excellent, looks great, thank you. Lock them up. Give it a good whack closed and lock them. Got them? All right. Iced and done. That looks good to me.
All right.
Well done, as always. With a planted area, you want most of the oil underground because we don't want to spray too much on the surface for them. So start putting in, take the trowel, and usually you just sort of scrape it across, try to get most of the dirt into the hole, and then the mulch will cover it up with. All right, let's give that a little spray, and then we'll kind of push some mulch on top of it. So we kind of spray it in layers. We spray the bottom of the hole first, then we fill in some dirt, and we spray a little bit on the dirt, and then we put over the mulch. And we don't spray the mulch typically. If there's any paper, grab it out of there. That wasp paper?
I think so.
Okay.
It's a little crispy, but I don't know.
Yeah, we'll take it. Anything with their pheromone we want gone or sprayed on. You see a little bit of the paper there, maybe next to your knees.
Yeah.
Creep all that into the hole and give it a spray. All right, so that nest has died down. No more activity here. A couple foragers returning, but they can't re-nest.
Here we see the Vespula flavopilosa, the Downy Yellowjacket nest, in its glass habitat where we're incubating the pupating larvae that will come out as adult wasps that we can then collect again for venom immunotherapy. The Downy Yellowjacket, flavopilosa, they are very hardy native wasps, and they take to captivity really well. They can survive very well on very limited food and water resources, and they continue to pupate out pretty rapidly without a whole lot of extra care. So in this footage of the nest, you'll see various forms of the development of the wasp. You'll see grub-like larvae that are not covered up by a silk cap in their cell yet. Their cell is still open. You can see their heads, and they are waiting to be fed by the adult wasps who will bring them food. And then in exchange for the food they're brought, they will give the adult wasps a liquid substance that they create that feeds the adult wasps. So it's a two-way feeding. The adults feed the baby wasps, so to speak, and the babies feed the adults. It's called trophallaxis. It's a fascinating evolutionary trait that they have. It gives both of them great incentive to take care of each other. The other developmental stage you'll see in this footage are pupating larvae that have gone into pupation and woven a white silk cap over the top of their cell, like you see here at the lower left frame. That is made out of proteins primarily. And all of the white silk caps you see here are larvae that have become mature enough to go into pupation. They'll stay in pupation for a couple of weeks, and then they'll chew their way out of that silk cap as adult wasps. The silk that wasps create is an amazing material. It's made out of proteins primarily, which is why larvae need so much protein. To go into pupation, to develop properly, and to weave their silk cap, they need a lot of protein. Once they get enough protein and they develop far enough, they will begin to create what's called silk dope. It's a gel that's created by glands inside their mouths. That gel-like silk dope becomes a very fine, very tough silk thread as soon as it hits oxygen. So they begin by threading a bit of this gel across the top of their cell, and it becomes a silk thread within seconds. And they just keep weaving and weaving and weaving until the whole thing's covered. Here on August 9th, 2025, you see the Vespula flavopilosa, the Downy Yellowjacket nest, feeding on pollen cake. We experimented throughout our 2025 season with feeding pollen cake as a protein source to multiple different species of wasps. And here you see the flavopilosa just ate it right up, just like all the other ones. We did it with bald-faced hornets, with paper wasps, with yellow jackets. Here a few days later on August 12th, they were doing just fine on pollen cake. They had no trouble at all using this as their sole food source. We had this and some water, and that's all they had in there, and they were doing great with it. So we haven't had any trouble with any of our species using pollen cake as protein and even a carbohydrate mix, because the pollen cake's actually made with plant-based proteins, but it has some carbohydrates in it and so forth too. Over here next door to the flavopilosa, you see squamosa, which is southern yellowjacket. They're also being fed exclusively with water and pollen cake, and they did just fine with it as well. So we're going to keep these experiments up. That's it for today's episode. Thanks for riding along with us. Have a good one.